Okay, the recording has started.
Okay, great. All right. Um, Thanks, Sarah, for getting all this going. Welcome to another Bionic Design Forum meeting today. We're a small subgroup of the e-NABLE community that keeps track of new developments in the area of bionic limbs, especially focused on low-cost 3D printing-enabled designs. So today we have the pleasure of um, Ben Lambright from Brandeis. He's a student there, I believe. And correct me if I'm wrong, Ben, and all this. And he's going to be talking, as we talked about last time, about the use of AI in prosthetics. So that, Ben, the floor is all yours.
Yeah, so I have a little bit to talk about here. My group has done some research, some preliminary research on using LLMs for prosthetics, both for developing prosthetics, um, describing how to create new prosthetics, and to modify existing prosthetics. So I'll go into each of those to some level of detail. So before what we've been doing, there's been some preliminary research on how LLMs and other machine learning models can be involved with the process of generating um, prosthetics and other 3D printed um, designs. And it's a very complex process because it's not natural text, which is what these models are trained on. It's essentially, you know, mathematics and software. So there has the existing research has been on having models walk users through how to modify or how to create certain 3D printed objects. This was a medical study, and it was done on prosthetics with some level of success, especially with newer users. Um, what we're trying to do is with some of these more advanced models, see if we can generate or modify existing prosthetics. So our research so far is that if you prompt some of these larger models, say ChatGPT has a reasoning model called O1. So if you use ChatGPT O1 and you prompt it for the specifics of, let's say, a hand, it is able to generate a boxy object file that looks like a hand. And this is printable, but it doesn't have any moving parts. It's just a single box. So, uh, what we're trying to do, given that, is see if we can prompt this model to effectively add joints, identify like the screws that are needed for these, and go through that process. And so we're trying to scale up from small to large. Probably the largest amount of this is, of course, we need to ensure that anything we produce is product ready. So a lot of us are working right now on um, automating a process to ensure that anything that is printed is, or anything that the LLM produces is printable. And if it is printed, it's like printed in such a way that has the supports that it doesn't collapse while being printed. So not only is the object not corrupted, but it can be printed safely. So that's a lot of the kind of work that needs to go into generating something like this. If you're going to automate um, creating that object file, you need to automate ensuring that it can be printed properly. So that's where a lot of our task and work has been focusing recently, because that is what needs to happen in order to ensure that we can print anything more advanced than like a very simple object. And the other stuff we're doing right now is seeing how, let's say we have a hand or another object, how we can safely modify these objects according to the prompt that we give one of these machine learning models. So yeah, that's what we've done so far. Are there any questions or things I could talk about more about the specific details on how we do this?
Yeah, love to hear the details. Just a quick question. When you say specific, safely, do you mean safety for the user, essentially, or
I
safety
mean,
for
when you're
printer?
printing these, and yes, safety for the user, but also that it has all of the supports to print correctly. So when you prompt a lot of these models initially, it doesn't include all of the supports, and so we had cases where the objects that we were trying to print might fall over it, for example. This is something a human might know, but that's because a human has an understanding of physics. And so right now we're seeing how we can ensure that there's some base level of physics understanding when generating these outputs.
Great, thanks.
Yeah. As for the details, we have a couple things which I could try to pull up for you all for the kind of software we're using to try and identify if these objects can be correctly printed. There are some, essentially we're trying to do everything as much as possible in Python. So we're trying to import some Python packages that can do that kind of physics understanding. So that way you import, so you have the LLM generate the object file, and then the object file is imported into this Python package that can identify if the object is printable, and then it returns an output of whether or not this object is printable and if it achieves the sort of goals which the user was asking for in the original prompt from the model. And so right now, a lot of this is also a lot of like, because we're still in like a sort of preliminary stage. If any of you have, let's say, like a subscription to a paid like ChatGPT, like ChatGPT Pro, some other LLMs also have this capability. You can actually prompt it right now, generate a 3D printable object of like a box or a hand, whatever you want, and it can actually generate this. And so we're taking that as a baseline, and we're seeing how we can optimize the prompts you give the model in order to have it generate a quality output, and to fine tune the model, which is when you give it a ton of data so that it knows exactly what the output should look like. And so another question down the line for us is, how are we going to get a lot of this data? And so right now we're considering, do we want to generate synthetic data of examples of 3D printed objects, or do we want to spend time web scraping databases to get examples of 3D printed objects and prompts that you would potentially use to generate them? So yeah, that's sort of our next steps, our future steps.
So do you have any examples, Bren, of how you do this? Do you have a demo you could share or something of how this works?
Yeah,
I
so
don't know what you have planned for today.
yeah, so I can see if I can get that shared. Um Unfortunately, I think, let me see just a moment. I had an example object file, so I'm going to see if I can pull it up for you. Um,
Yeah, that would be useful
yeah.
just to see
Yeah,
what it produced.
yeah. So right now it's really boxy. I have to pull up another um, computer where I had it stored. Um, taking a second to pull it up. So I'm having trouble pulling it up right now because I'm at work. Um,
Okay.
and it was this done on my personal laptop. I tried to go through some files, which I know I have. Um, yeah, but I work in Cambridge, so it's a little bit difficult
Huh?
for me to get it. But
So,
essentially,
are you not you? Sorry, go ahead.
essentially what it looks like is um like it's a it's essentially they take a rectangle and they add a finger rectangles for each finger. Um, so it's essentially just one large rectangle appended to five small ones. So there's no joints, there's no screws. It's just a box essentially right now. And so we think that the best path forward from moving on from this box is um, by seeing if we can add joints and things like that. And the other thing we're trying is if we import an existing prosthetic image, um, what does the like are we able to modify it without like completely changing the image? So that's something we have tried. We've uploaded some existing like prosthetic hands and we're like increase the size or decrease the size. And right now the models have had trouble doing that. And so that's where, as I mentioned in our next steps, we want to give it examples, several of examples of like existing prosthetic hands. And we give it the prompt increase or decrease, um, and seeing if that increases or decreases the prosthetic hand correctly once we give it examples. So that's sort of our next step because we see generating it from scratch in this way would be probably um, a very data like intensive project. Um, just because you know you can generate that boxy hand, but going farther from that and getting into like the great complexities into like these more advanced object files is something that an LLM is not capable of right now. So that's why, given that sort of boxy image, we're trying to transition to see if we can have it just modify small parts of an existing object file.
Right, right. So LLMs, I don't know much about LLMs, so so LLMs as they stand now, you can't just show it an image of a phoenix and say, make this bigger or smaller, or add a joint or whatever. Is that correct?
Right now, it looks like um, it's not capable of doing that without making it difficult to correctly print the object. So it might add
Okay.
it, but it's going to change the image or the object, I mean, significantly. So we're trying to add
Right.
more guardrails to ensure that it does this in a way that still makes the hand usable.
Yep. Yep. So I have a few more questions, but Jonathan or anyone else, if you want to chime in with any questions you have for Ben, please go ahead.
I guess I don't really have a whole lot of like input. I guess it's all it's all kind of over my head, like I've said before in some of Ian's meetings too. But is there anything we could do as volunteers to give you guys as resources to help out?
I think the most like helpful thing for us is if you could point to more like data sets that exist of prosthetics, like specifically prosthetic hands. I know they're the ones in the e-NABLE hub, but if there are any other ones that you know of, especially if they're similar hands but like modified slightly, so that we can
Okay,
show like an LLM, here's how you modify it slightly without hurting the design.
gotcha. Yeah, I don't think we necessarily have any like we kind of have a few repositories, but yeah, they're kind of a lot of the designs are pretty well different from each other.
Right, right.
So the objective would be if we find a design that's slightly different from Phoenix, let's say some Phoenix
Yeah,
V3, and feed it to the LLM and see if it can modify the box to emulate this. Is that
that's
kind of
correct.
what you?
So we would want to do, like, let's say we use the Phoenix hand. And let's say there's a version of the Phoenix hand that is, let's say, just a small percentage smaller. If one exists, we would prompt the LLM. We want, given this Phoenix hand, create a version of it that is just a certain percentage smaller, and that way we can compare it with what actually exists. And that way, when the LLM can correct itself because it has an example of what it should look like.
Right.
Right.
Right. Got it. Yeah. So, is this work continuing next semester, or where does it stand? Are you continuing this work yourself, or
So
is it being?
I'm with a
Okay.
group of 5 or so people, um, and I work full time right now, so it's difficult for me to do as much research on it. But a couple of the other folks are doing uh, some like preliminary research to get this started, because we started a different project related to LLMs and e-NABLE last spring, and now we're trying to transition into this, and so we're still in like a research phase.
Okay. And
And
this group is this group is with Ian Roy's
yes, yeah,
lab? Okay.
yeah, and we're hoping to continue at least this to some extent in the fall.
Yeah,
Okay.
I think Vivek, we propose that they come up with some preliminary stuff before we make like a Lumio proposal for funding.
Yeah,
So I think that's kind of the stage we're in now.
Okay. Okay.
yeah, we're hoping to get a demo, like a more working demo, um, before we do a Lumio proposal. So that way folks can see, here's what we're able to generate right now.
Okay. Got it. Yep. Okay. Well, I don't have any more questions. Anyone else? I guess it's just the four of us on the call today.
Yes, so
So
yeah.
Okay. Well, appreciate your time.
Thank you.
Ben, thanks for taking the time to present this. I myself don't know anything about LLMs, so I'm sorry I can't offer any any
That's okay.
meaningful advice. It's all moving so fast, I have no idea what's going on.
It really is.
So,
It really is.
yeah. I used to work on AI in the 90s, and that was all rule-based stuff. It was
Right. That was a different time,
new,
especially language processing.
yeah, new neural nets were in their infancy, but
They
now we're
were.
talking about 100 layers and trillions of billions of connections, and it's insane.
Yeah,
Anyway,
it really is.
all right. I
All right.
guess if there are no more questions, thank you again for your time, and thanks, Sarah, for setting this up.
Yeah. Thank you, everyone, and thank you, Ben. I am sending a link of this presentation to John and um Ian, and then if it's okay with you, I'll also include it in next month's newsletter so that um the community can take a look and watch the recording. And yeah, if there's nothing else, we can end early. Thank you so much.
Okay,
Thank you, guys.
thanks. Have a good weekend.